All right, welcome back, folks. So just a few more things to touch on in terms of different types of sediment and kind of recapping the distribution of sediments and then finishing up with sampling methods. So here we go. So we're gonna jump into now the last two types of sediments that are out there. We're not gonna focus on them a whole lot, but I'd like to mention them just so we are familiarized with them. So here we go. We're going to start with hydrogenous sediments. So hydrogenous, in a simple way, just means that there's a chemical reaction that's going on that's changing the composition of that rock or of that piece of black smoker stuff. So four main sorry, let me move my face here. Four main types of hydrogenous sediments include manganese nodules. They kind of look like, I don't know if anyone here is familiar with truffles, but they kind of look like little truffles to me. And then we have carbonates or ooliths, which are kind of interesting, almost looks like styrofoam in a way. Then we have metal sulfides. So we talked about these ones already. And this we talked about when we talked about hydrothermal vents. So we have the water reacting with the precipitation of the black smoker, and then that's then sedimenting or falling down and precipitating onto the local area there, right? So this is a beautiful example of a hydrogenous sediment. And then there's also evaporites. So things like salt. This is basically a picture of a dried salt, almost lake bed in a way. So these can be left behind as well. I think your book goes into some other examples also. So do keep in mind, especially with the smart book readings, that there are other examples there too. The last one are cosmogenous sediments. So cosmogenous simply means of the cosmos, of the space. So, you know, our planet was built with a lot of collisions. If you think of proto-Earth or early Earth, thinking back to some of our early lectures, you know, they've come from space. And we're still being bombarded with very small meteorites, not, of course, not nearly as violent as when we were first born as a planet, but we get up to 300,000 tons a year 300,000 tons per year still make it to Earth. So that's kind of crazy. And much are in the form of tektites or microscopic silicates that can show evidence of being created by impact events, you know, mostly composed of iron and nickel. So kind of cool. Kind of cool. Usually the space dust dissolves in water, but some of it can be, like the tektites, can be deposited on the ocean floor. So pretty neat. So if we were to look at a whole kind of overview of everything we just talked about in the last several recordings, looking at, this is like, I think, in my opinion, a really nice overview of everything. So closer to our continental shelf is over here on the left-hand side, so closer to the continent, right? We have things like biogenous coral and macroscopic debris or hydrogenous evaporites. Then out into the shallow water area, we have shelf lithogenous sediments, which are coarser. We have some turbidity currents, right? Those kind of circular things that go down, which can give us sea fans, versus, you know, our micrometeorite debris, volcanic and wind-blown dust, which can eventually make it to the bottom of the ocean. It can sink, you know, over long periods of time. And then we have our deep or pelagic sediments, of course, that consist of our silicous tests and calcareous tests in our cold water and warm water, respectively. And we have our calcareous ooze here at the top of the mid-ocean ridge areas and silicous ooze that can only exist underneath that 4,500 meter mark, or that calcium composition depth. And yeah, so I just think this is take some time to look over this slide. I think it's really quite neat to get a nice overview of the various things we just talked about. And here are just some various examples of maybe some of the sand or sediments that you've come across before. So in the top left, this is just a picture of Fort Funston. So that's right north of where you may be located. We may try and go on a, not in this class, but maybe in the labs, try to go on a field trip here. What's really cool about Fort Funston, if you ever have the opportunity to go, the bluffs are made of this really interesting kind of browner sand. And if you go down onto the beach area, there's actually, the sand is rather magnetic. And so if you take magnets with you, if you accidentally drop your phone, you can find that it actually sticks to your phone, which is kind of interesting. This is the island of Koh Tao in Thailand. So notice how the sand here is really, really white. You can probably imagine it's quite fine and beautiful, and it is, can attest to that. This image here is from Glass Beach in Fort Bragg, which is north of here about 3 hours or so. If you've never been, I highly recommend it. It's really quite neat. The glass is very well rubbed down by the water, so it's not sharp or anything like that, but it is really quite neat. And then this is just an example of a black sand beach. There's tons of different black sand beaches out there. There's several in Hawaii, as well as Iceland, and really anywhere where there's a volcano. But maybe you're familiar with those. So really, really quite cool. What's always quite sad, I think, about black sand beaches is if there's ever any coral bleaching going on around the black sand beaches, it really does a number. It's really a stark contrast, the white of the coral against the black sand beach. It really makes it honestly quite sad. So again, thinking of all of this and bringing this all together, summarizing it basically of all these different sediment types and where they kind of deposit themselves, how far they can travel, etc. And thinking about the percentage of the ocean floor, that's what this table is here for. So the continental margin regions consist of only 22% of the total ocean floor, but they contain about 87% of the total volume of marine sediments. That's pretty impressive, right? So they take up only almost a quarter of the ocean floor volume, or percentage of the ocean floor, but they have worlds more of the total volume of sediments, which is really quite crazy, right? And then in contrast, the deep ocean floor, including the mid-ocean ridges, consists of roughly 78% of the total ocean floor, but only 13% of the total volume of marine sediments. This is pretty dang telling, right? It's pretty freaking wild. And then looking at the sediment thickness, the coastal margins are so much thicker than the deep ocean floor, right? That makes sense though, because a lot of the coastal margins have the more coarse sediments that just sink a heck of a lot faster. So they're going to build up closer to the continents and not travel thousands of miles to the middle of the ocean and then eventually fall down to the bottom of the ocean, which again, it takes a whole heck of a lot of time to get down there. So the thickness near the coastal regions is much greater than in the deep oceans. And so this goes back to this map again, right? So the redder colors indicating the thicker sediments, the cooler colors indicating the thinner sediments, and we can really nicely see the thicker sediments, especially off the east coast of the United States, but even off of northern South America, and especially, frankly, off the coast of India and Bangladesh. Lots of thick action going on there, right? So it's really quite fascinating, I think. So, you have this idea in numbers, you have it on a map, you have it all over the place, and we can really kind of bring home that whole idea that our thicker sediments are closer to the continent and our thinner sediments are further out in the deep oceans. So with that, when we come back in person, I don't want to really take up too much more time. We'll talk about different sampling methods, how we know all of this stuff, about the different types of sediments, what they're made up of and things like that. So we'll go through the details of that when we come back in person. And with all of that, thanks again so much for your time and attention, and we'll see you soon. All right, cheers. Bye.